In this example, we want to take each of these equations in part A and B and write them in standard form so we can identify the center and radius of the circle. So just let's recall what the standard form of the equation of a circle is. This is when we write the equation in the form x minus h squared plus y minus k squared equals r squared. So when we have a circle, an equation for a circle written in this form, we can identify the center that has coordinates hk, and the radius is equal to the value of r. Okay, so first taking a look at part A, this is essentially already in standard form. So we've got x plus 2, and so I can write that as x minus 2 squared plus y, we can write that as y minus 0 squared, is equal to 100. And so to figure out what r is, the radius, that's going to equal the square root of the constant on the right side of the equation, which is 10. So here we can identify this as 10 squared. So we've already got this written in standard form, and this tells us that the center is located at minus 2, 0, and the radius is 10. So this was the center. Okay, so that was part A. In part B, we're going to have a little bit of work to do here, since this is a bit further off from being in the standard form. So when we write the circle in standard form, notice that we have x's, y's, and constants. These are all separated. So let's start by separating and grouping our like terms. So that means in B, we're going to take the 2x squared and group it with the 4x. We're going to take the 2y squared and group it with the minus 16y. And then we're going to move the 24 to the other side of the equation by subtracting 24. So we're going to group like terms first. And now what we want to do is take these terms that have x's and y's and write them as a perfect square, where the coefficient in front of the x and y, this should be 1. So the coefficient now in front of the squared term for x and y is 2. So let's divide everything in this equation, both sides of the equation, by 2. So we start to move in the direction of putting it in the standard form. Okay, so dividing both sides of the equation by 2 would then give me, on the left side, we've got x squared plus 2x. I'm going to just leave a little placeholder here. We've got y squared minus 8y. And then we also need to divide the right side of the equation, and that gives us minus 12. And what we'd like to have on the left side are the x terms and the y terms. We'd like these to be perfect squares. So in order to do that, we're going to need to complete the square. So recall what we mean by a perfect square. So something such as x plus p squared, that's a perfect square. And that has a certain algebraic form, which is x squared plus 2px plus p squared. So we're going to want to recognize that form. So for the x terms, we have 2p is equal to 2. So that means p is 1. And we're going to want to add p squared equals 1 squared equals 1 to both sides. So I'm going to add a 1 over here, and I'm going to add a 1 over here. And same story with the y terms. So here we see that 2p is equal to minus 8. So p is minus 4, and p squared is minus 4 squared, which is 16. So I'm going to add 16 to complete that square, and to keep this equation balanced, I'm going to add it to the left side, the right side as well. So now the x terms are going to look like x plus p, which was 1 squared. The y terms look like y plus p, and there our p was minus 4 squared. And then grouping the constants on the right side of the equation, this gives us 5. Okay, so this stuff over here, once I added the 1, that is equal to x plus 1 squared. It's a complete square. And once I added the 16 over here, that completes the square for the y terms, and that's equal to y minus 4 squared. So now this equation is in standard form. And from this, we can identify that the center HK is at minus 1, 4, and the radius R is equal to the square root of the constant on the right side, which is 5.